Good morning, students. Chapter 4, motion in plane. Yes, it is continue. We'll see some questions here for chapter number 4. See, a boat can move in river water with a speed of 8 km per hour. This boat has to reach to a place from one bank of river to a place which is in perpendicular direction on the other bank of river. Question 1. In which direction should the boat has to be moved? Question 2. If width of river is 600 meter, what is time taken by the boat to cross river? The river flows with velocity 4 km per hour. Now see, understand this data. A boat can move in river with a speed 8 km per hour. Boat is moving in water, so it is nothing but speed of boat with respect to water, because boat is moving in water. So understand this data. A boat can move in river water with a speed of 8 km per hour. So this 8 km per hour is speed of boat with respect to water. Then how to write? See, speed of boat with respect to water. How to write it? V B W, speed of boat with respect to water. It is 8 km per hour. Okay, now this last statement. See, the river flows with velocity 4 km per hour. River flows means water is flowing in river. Yes, water in river is flowing with respect to ground. Yes, with respect to earth. Okay, yes, so the river flows with velocity 4 km per hour. It means speed of water with respect to ground, VWG is equal to, here it is 4 km per hour. So first of all, how to write data? Understand, okay? The river flows with velocity 4 km per hour. River means water is flowing in river with respect to ground, because water is changing its position with respect to ground. Yes. So speed of water with respect to ground, VWG is equal to 4 km per hour. Okay, it is speed. That's why we have indicated on the magnitude. Okay. Now, what is your question? See, we will draw a river. Let it is river. Okay, two banks of river, water is flowing. Okay, now see, the boat has to reach to a place from one bank of river to a place which is in perpendicular direction on the other bank of river. Means river. Yes, it is river. A person is supposed here from on one bank of river. He wants to move on other bank, but see, to a place which is in perpendicular direction. Means he wants to reach at this point. Clear about this? What is target? Boat has to move from this point to perpendicular distance on another point. Okay. Now, question is, in which direction should the boat has to be moved? If initially boat is moving in this direction, okay, suppose it is VBW, the boat is moving in this direction. Yes or no? Yes. Water is flowing, the river flows with velocity 4 km per hour. Suppose water is flowing in this direction. Okay, so how to indicate this? Velocity of water with respect to ground, that it is in this direction from this same common point. It is VWG. So see, from this one point, boat is moving in this direction, water is moving in this direction. See, if you have observed in river, whenever you swim in river, you will move in direction of flow. So if river is flowing in this direction, and if you start your motion in this direction, what will be your resultant direction? See, if you complete this parallelogram, you will move in this direction. You will move in this direction. Clear about this? Clear about this? So initially, if I am starting in this direction, that is perpendicular direction, will I reach at this point? No. You will reach at some another point. You will reach at some another point. Clear about it? Okay. So if I want to reach from this point to this point, then what I have to do? What is solution? Yes, solution is you do not have to move in this direction, but you have to move at some angle. You have to move at some angle like this. See, if it is river, okay, it is one reference point. Water is flowing in this direction. See, water is flowing in this direction. Okay, so it is VWG. It is VWG. Clear about this? Clear about this? Now, if I want to reach at this perpendicular distance, and if I move both in this direction, okay, it is VBW. It is VBW. Then what happens? Okay, if this angle is theta, then what happens? See, from this same common point, first vector, another vector. If I complete parallelogram, okay, and if resultant velocity is in this direction, okay, then I will reach at this same point. What is difference between these two figures? See, if in starting I am moving directly towards perpendicular point, river is flowing in this direction, then what is the resultant velocity? The resultant velocity is in this direction, means I will reach to this point, not this perpendicular point. But if I want to reach this perpendicular point from this, then if I am moving boat initially in this direction, velocity of water is in this direction, then yes, boat is moving in this direction, velocity is in this direction, boat is moving in this direction, velocity in this direction, I will reach to this point. Yes, what is practical example? Practical example is end of one movie, Mohenjo-daro. Okay, if you have seen that movie in Mohenjo-daro, see, in the last scene, okay, to cross river, the hero makes one bridge with the help of some boats on river. If you have observed, okay, what he did? He placed boats like this and he released this end. So due to flow of water in this direction, these all boats are linked in this direction. Okay, and makes one bridge. So yes, whenever you are moving in some flow, your direction is changing. Clear? So yes, if we are moving in directly in this direction, we will not reach at the same perpendicular point, but we will be moved away. So what is conclusion of this point? If you have to start from this point and you want to reach at this point, you have to move both at some angle. And yes, you have to find this angle here. Okay, now what happens? Water is going in this direction, boat is moving in this direction. So what is the resultant velocity? Resultant velocity of boat with respect to ground, it is VBG. VBG means velocity of boat with respect to ground. VBG is velocity, or yes, I can say the speed of boat with respect to ground. Now you may ask me one question, sir, why to find speed of boat with respect to ground? It is point on ground. It is also point on ground. Okay, boat has to move from one point on ground to another point on ground. So we have to find VBG. Clear about this? Okay, so yes, we are given to velocity VWG, VBW, and the resultant is VBG. You have to find this angle theta. How to find this angle theta? Okay, see here. First of all, what is relation between these three vectors? See, if you use parallelogram, first vector, second vector, from that common point, okay, if you complete parallelogram, then it is resultant. Then here, what is relation between them? Here, V, B, G is equal to V, B, W plus V, W, G. It is relation between these three vectors. These two vectors, and the resultant is V, B, G. Now see, I am assuming it is x-axis and it is y-axis. Yes, here I can also represent it is x-axis and yes, it is y-axis. Okay, so now I will take their components. I will take their components. See how to take components. First of all, I am taking x component of this equation. Take x component. Take x component. See, VBG, here it is, VBG. VBG makes angle 90 degree. VBG makes angle 90 degree with x-axis. See, it is clear. It is VBG. It is x-axis. It is making angle 90 degree. So how to write? See how to write. VBG, that is x component is VBG cos 90. Clear about this? Clear about this? How to write? Below VBG, you have to write its x component is equal to, then yes, here it is equal to VBW, yes, here it is VBW. This VBW vector, it is in this direction and it makes angle with x-axis, so it is 90 plus theta. Again, it is VBW, this VBW makes angle theta plus 90 with x-axis. So how to write? It is VBW cos 90 plus theta. Okay, then VWG. See this VWG, it is in x direction, means it makes angle 0 with x-axis. Then how to write? Plus VWG cos 0. Clear about this? How to write components? How to write components? Now VBG cos 90. You know, students, what is value of cos 90? Cos 90 is 0. Is equal to VBW cos 90 plus theta means, yes, it is minus sin theta plus, it is minus sin theta plus VWG cos 0. VWG cos 0. Cos 0 means 1. So yes, it is only plus VWG. Clear about this? Clear about this? Okay, okay. Now, how to put value? You can write this equation this side. What is VBW? What is VBW? VBW is 8. So yes, 0 is equal to minus 8 sin theta plus VWG is 4. So yes, it is 8 sin theta is equal to 4. So therefore, sin theta is equal to 4 by 8 is equal to 1 by 2. And you know for which angle value of sine is 1 by 2? So theta is equal to, it is 30 degree. Theta is equal to, it is 30 degree. So what is your first answer? You have to move board at angle 30 degree with this perpendicular line. With this perpendicular line. So if you move your board at angle 30 degree with this y-axis, then and then you will move to this perpendicular point. Otherwise, you will reach at some other point and not perpendicular point. Clear about this? Okay. Now, yes, first answer, theta is equal to 30. Now, second question. If width of this river is 600 meter, then what time it will take to cross this river? See, perpendicular distance between two ends is 600 meter. What is relative velocity in this direction? It is VBG. What is relative velocity in this direction? What is resultant velocity in this direction? It is VBG. So see, to use equation, speed is equal to distance upon time. Speed is equal to distance upon time. You have to find this VBG. You have to find this VBG. Because see, perpendicular distance between two bank is 600. And yes, in this direction, that is perpendicular direction, what is speed? It is VBG. So yes, you have to find VBG. How to find VBG? Take y component of this equation. See, take y component, take y component of equation. See how to take y component. It is easy. Yes, you can directly write in this equation. You can directly write in this equation. Okay. to make y component, yes, you have to replace cos by sine. You have to replace cos by sine. Yes, here how to write? It is VBG sine 90 is equal to VBW sine 90 plus theta, sine 90 plus theta plus VWG sine theta. Or yes, I can say the sine. Yes, it is sine. Clear about this? Clear about this? Okay. So yes, what you have to find? Yes, you have to find VBG. So yes, VBG. What is value of sine 90? It is 1. VBW. Where is VBW? VBW it is 8. VBW is 8. Sine. Yes, you know value of sine. Sine 90 plus theta. It is cos theta. It is cos theta plus sine 0 0 means yes, it is 0. It is 0. Then yes, VBG is equal to, it is 8. Cos, what is value of theta? 30. It is cos 30 is equal to 8. Cos 30 means root 3 by 2 means it is 0.866. Then yes, if you multiply this, you will get your answer 6.93 kilometer per hour. Clear about this? Then see, yes, we have value of VBG. VBG is equal to 6.93 kilometer per hour. It means if river is flowing in this direction with 4 kilometer per hour, boat is moving in this direction with 8 kilometer per hour, then what is resultant velocity of boat with respect to ground in this direction? It is 6.93 kilometer per hour. Clear? And see, with this 6.93 kilometer per hour, it travels 600 meter distance. Then how to find time? Yes, how to find time? Time is equal to distance. Time is equal to distance upon speed. Okay, so yes, it is VBG upon distance. What is value of VBG? What? You have to find distance. What is value of distance? Yes, it is 600 meter. 600 meter means I can write it as 0.6 kilometer. Why to convert in kilometer? Because see, this speed is in kilometer per hour. So it is 6.93 kilometer per hour. Okay, and if you calculate, you will get your answer is equal to 0.8658 hours. Clear about this? So yes, it is one important question that clears your concept regarding resultant velocity. Clear about this? Okay, yes, whenever you are moving in a medium which is also flowing, then your direction changes due to resultant velocity. Clear about this? Write down. Two objects are projected with the same velocity at different angles with the horizontal, and if the range is same for both of them, then prove that T1 T2 is equal to 2r upon g, where T1 and T2 are their time of flights. See, understand question. Two objects are thrown with the same velocity at different angles with the horizontal, and if the range is same, see here, range is same. What is meaning of this? Yes, if you know result, if range is same, okay, then theta 1 plus theta 2 is equal to 90 degree. Means angle of projection for one particle is theta 1, angle of projection for second particle is theta 2, then addition of that is 90 degree. How? See. V0 yes, it is also V0 as you are given. Two objects are thrown with the same velocity at different angles. Like for this one, angle is theta 1, and for this angle is theta 2. Different angles with horizontal, and if range is same, yes, we know one result. If range is same. Here R1 and here R2. So yes, R1 is equal to R2 when theta 1 plus theta 2 is equal to 90 degree. You know this result. Yes, you know this result. Clear about this? Okay. Then what you have to find? Both of them, then prove that T1, T2 is equal to 2R upon G. Yes, range is same. So we can write R1 is equal to R2 is equal to R. Okay. Where T1 and T2 are their time of flights. So see, first of all, we will find time of flight for these two cases. Okay. What is equation of time of flight? Time of flight. Time of flight. TF is equal to 2 V0 sine theta 0 upon G. Yes, it is equation of time of flight. See, for this first one, T1 is equal to 2, initial speed is V0 sine theta 1, because angle is theta 1 upon G. Simple. Yes, it is simple. Okay, for this one, T2 is equal, it is 2 V0 sine theta 2 upon G. Yes, here I will change one thing. See, theta 1 plus theta 2 is equal to 90 degree. So I can write theta 2 is equal to 90 minus theta 1. Yes, I can write. Okay, theta 2 is equal to 90 minus theta 1. So here I will put its value. T2 is equal to 2 V0 sine theta 2 means 90 minus theta 1 upon G. Now students, you know what result? Sin 90 minus theta means cos theta. So T2 is equal to, it is 2V0 cos theta 1 upon G. Cos theta 1 upon G. Clear about this? Clear about this? So yes, if you are given T1, T2 is equal to 2R upon G. So first of all find what is T1, then find what is T2. Okay, now we will start from left hand side. LHS. LHS is equal to, what is LHS? T1, T2. T1, T2 is equal to, what is value of T1? 2 V0 sine theta 0 upon G. T2, it is 2 V0 cos theta 0 upon G. So yes, put value of T1 and T2 from LHS. From LHS, it is T1, it is T2. Put value of T1 and T2. Okay, now see how to writing form is equal to, how to write this. See, this 2 as it is. V0 into V0, V0 square. This 2, here it is. Sin theta 0, cos theta 0. Okay, yes, each and every term 2, yes, 2. V0 into V0, V0 square, sin theta 0, cos theta 0. Upon, it is G square. Upon, it is G square. Or yes, I can also write it is G into G. Yes, it is G into G. Yes or no? Yes. Now observe this term. 2 sin theta cos theta. Yes, you know it is sin 2 theta. So how to write this? 2 V0 square sin 2 theta sin 2 theta. Yes, it is theta 1. Then yes, you can write here it is theta 1. Yes, it is theta 1 and theta 1. Then it is 2 sin theta 1 divided by this G and this G. Observe this equation. V0 square sin 2 theta 1 upon G. If you remember equation of range. See, for this first case, what is equation of range? If you write, then R1 is equal to V0 square sin 2 theta 1 upon G. Yes, it is equation of range. And as range is the same, R1 is equal to R2 is equal to, I can write R. So yes, R1 is equal to V0 square sin 2 theta 1 upon G. So here I can replace this V0 square sin 2 theta 1 upon G by R. So yes, it is 2R upon G is equal to, it is RHS. Clear about this? So yes, it is one question in which you have to prove one relation. And yes, see, whenever you are given questions like this, okay, you have to prove some equation. Remember that result. Okay, yes, this equation is used. T1, T2 is equal to 2R upon G to solve numbers of MCQs. To solve numbers of MCQs. So whenever you are given in textbook or in another material some questions of prove that and result that you have to remember. Clear about this? Right now.